Prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. So the trick behind doing these kind of questions when it comes to inverse with numbers is that you got to change each of them to tan inverse. Why? Because you only have the formula for tan inverse of x plus tan inverse of y is going to be tan inverse of x plus y over 1 minus xy, or tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y over 1 plus xy. So you have the formulas only with tan inverse. You don't have it for sine inverse or cos inverse. So change each of them to the tan inverse form. So changing cos inverse of 4 by 5. So we know that cos is adjacent over hypotenuse. So you can draw any triangle, a right triangle. Let's name it as ABC, right angle at B. So let me consider one of the acute angles. You can either consider A or C. Let's consider A. So with respect to A, as it is cos inverse, 4 is the adjacent side, 5 is the hypotenuse. So you can solve for the opposite side. But we also know that it's a Pythagorean triplet, 3, 4, 5. So this is supposed to be 3, or you can solve by Pythagoras theorem. You'll get that as 3. So cos inverse of 4 by 5 is also same as tan inverse of opposite over adjacent, 3 over 4. Why? Because both of these are equal to the angle A. So I can say that they are equal to one another. So same way, you can change the other one, that is cos inverse of 12 by 13 to tan inverse. So again, you draw another triangle, DEF. Let's consider angle D. With respect to D, since it's cos inverse of 12 over 13, again, cos is adjacent over hypotenuse. So the adjacent of angle D is 12, hypotenuse is 13. So again, the Pythagoras triplet is 5, 12, 13. So it's 5. Or you can solve that by Pythagoras theorem. So now this is same as tan inverse of opposite over adjacent, 5 over 12. So the LHS finally becomes tan inverse of 3 over 4 plus tan inverse of 5 over 12. Now using the formula, that is the one I noted over here, I can use this formula. So that's going to be tan inverse of 3 over 4 plus 5 over 12 over 1 minus 3 over 4 times 5 over 12, making the denominator same. That is multiplying this with 3. I would get tan inverse of 9 plus 15, 14 over 12 over 1 minus, this could be cancelled. Okay, that's going to be 1 over 1 minus 5 over 16. That becomes tan inverse of 14 over 12, 16 minus 5 over 16. That's going to be tan inverse of 14 over 12 times 16 over 9. Simplifying it, that's 3, that's 4, and that's going to be, yeah, that's what you do. That's tan inverse of 56 over 27. I'm sorry, this is supposed to be 11 over here. There's a mistake. That's supposed to be 11. Okay. And yeah, this is supposed to be 33. Now on the right side, we need cos inverse. So changing this tan inverse to cos inverse. Again, we need to take a right triangle. Yeah, I'm going to consider a right triangle. So that's, since it's tan inverse, uh, let's name it as Hij. Let me consider the acute angle H. So with respect to that, tan is opposite over adjacent. So this is 56, 33. Solving for the hypotenuse using Pythagoras theorem, you'll get as 65. So that's going to be cos inverse of adjacent over hypotenuse. That's same as the RHS. That's how you solve this.